Hello and welcome everyone. Today we are going to talk about data types and as any other OOP language, C# also has a lot of data types, but these are just like normal data types, so nothing to worry about them. We are going to discuss all of them here. So the first one we are going to talk about is Boolean data type, which could be either true or false. The default is false. So the way you define is bool is valid. For example, here our variable name is valid and we assign the value true. And if we run this program, it's going to print true. And the same way, I'm going to just move these commits a little bit below so that we can discuss the next one. So the second one is signed integers. So the signed integers or integrals in C# are those data types who has like signs minus or plus values in them. So the first one we are going to talk about is S byte. So S byte has a size of 8 bits and it ranges from minus 128 to 127 and the default value is 0. For example, you can have a variable temperature S byte and you can assign the value to -4, and when you run the program it's going to print -4. And similarly, the next one is going to be type short. So the property short has a size of 16 bits and its range is 32,768 to 32,767. It should be minus here, so I'm gonna put minus. So how do you calculate that? This one here is very simple because it's 16 bits, so you just do 2 raised to power 16 minus 1. So then you actually achieve this number here. So this is gonna be here like this because it's signed integer, so 1 is reserved for the symbol itself. So this was short, and the next one is the type integer itself. This is the most commonly used data type for the numbers. If you are dealing with numbers, so you most probably are going to use the type integer or int in short. It has a size of 32 bits and its range is 2 raised to power 32 minus 1 to minus 2 raised to power 32 minus 1. And just like other integral values, it also has a default value of 0. So here we have a variable total request, and the value we are assigning, you can also assign like this way because it's a mathematical expression and the compiler is gonna assign the value on runtime. So the value we have is 2 raised to power 30, and when you will run it, most probably we will get a value in scientific notation 28, which is not correct here. Let me check. Okay, so it actually did not work the way we want. So it's like we have to use the system dot. For some reason my IntelliSense is not working. I'm gonna check and we'll be back in a while. So it seems like the way we were assigning the power is not working, so I just created a method, static method power here. We're gonna talk about functions later on, but right now you can just understand like this function is taking two parameters. The first one is gonna be the base one and the second one is gonna be raised to the power. So for example here, to total request, I'm gonna assign a value of 2 raised to power 30. So let's just run it and see. As you can see, like we get a very huge value. It is 32-bit and it is assigned to a variable which has a data type integer. So our next type is long. It has a size of 64-bit and its range is from 2 raised to power 64 minus 1 to minus 2 raised to power 64 minus 1, and the default value is 0L. Here you will see a difference, like we have a suffix L. Here L represents that the value of this variable has a data type long. So wherever you have to specify a long value to a variable, you can you should actually specify L. It's a language according to language specification. If you specify the suffix L, it's gonna be pretty clear that it's a long value. So it's wrong here, so I'm gonna assign long nanoseconds, and here we are gonna take the same method. So I'm gonna use power off, and here I'm gonna use minus 2 raised to power 60 because my function is using integers as data type, but as we know that integer cannot handle any value more than 32 bits, so I have to actually alter the function itself to return the data type long. So I have to take anything and then return anything in data type of long. So just let's run it and see what we get. So we get a pretty long value, which is actually pretty nice, and it has a data type of long. Pretty nice, isn't it? Cool. So let's move forward. The next data type. So these were the signed integral part in C#. And the next part is unsigned integrals. So where the value has no negative value, you can just put in your mind that all the values, they are just positive values, no negative value. So the first one is byte. It has a size of 8 bits. Its range is from 0 to 255. Why? It's like 2 raised to power 2 raised to power 8 is gonna be 256 minus 1, which is 255. It's actually a bit different than here, because here when you calculate this range for signed integral, you actually calculate power in this way, that you actually put minus 1 on power, and then you calculate the power of 2. The value you get is the range there. But here it's a bit different, because there is we don't need to specify any space for the signed value itself, so we are just gonna calculate in this way. Yeah, so we have a byte here. Network ID, for example, its value is 227. We will write it, it's gonna be 227. So I'm not gonna run it, it's gonna take a bit, so I'm gonna discuss, for example, till here, and then after that I will run all of them before floating points. So the next one type is ushort. It has a size of 16 bits, and its range is from 0 to 2 raised to power 16 minus 1. So the default value is 0, just like any other integral value in C#. So here I'm gonna use the same function here, power off, and if I use power off, again the problem is like I have to change those parameter types here. So we are working with ushort, it will return a value in ushort. And here I can see the cannot convert from integer to ushort. Why? That's pretty amazing, because it's assuming that I'm actually like reducing a value, and it could be integer, because here 1 is integer, it's not ushort. So in this way we cannot go, but we can go just like integer way, because it has 2 raised to power 16, so we will make sure that we don't exceed 2 raised to power 15. So I'm gonna just convert them to int, and int here, but there will be a problem that the value returned is integer. So here the return value will be integer. But there is a nice way that if you wanna get the value in another format, and especially if you're converting a value between numeric to numeric value, the easiest way you put conversion in this way. So in bracket you just write the data type and that value. If that has the same capacity as this data type, so it will return to this data type. Even if the value is bigger, it's gonna ignore the rest of the value, but you will get kind of random value with some calculations. But make sure that the value which is being returned by any function or any other data type is not more than this data type. In our case, we know that power of 2 raised to power is for sure gonna be is for sure gonna be below this range. So yeah, it's fine here. The next one is data type uint, and the size is 32 bits, and the range is from 0 to 2 raised to power 32 minus 1. The default value again is 0. We have, for example, I'm gonna change this function one more time. The reason, because the next one is 64 bits, and integer does not return any data type more than that. So I'm gonna change it to long, just take even less. I mean, we know the arguments, there are 2 and some power, which are just like small values. We can use even some small data type there, but just to be on the safe side. So yeah, here again we will copy this one from here to here, and here from, so here we are just converting the value which is returned by this function to uint. And the next data type is ulong, which has a size of 64 bits, and the range is from 0 to 2 raised to power 64 minus 1. The default value is just like 0, just like another numeric value in C#. Here we have a variable ulong distance, and the value is gonna be 2 raised to power 60. So here 2 raised to power 60, and I'm gonna convert this to ulong. Make sure to end up your statement with a semicolon. And here is 2 raised to power 15. It's gonna be the same value, but to make it different, I'm gonna pick any other number. Let's make it 31 here. So these were more or less numeric values, signed and unsigned, and just to make sure that I'm not running the rest of them. So let's run and see. It should be 227, some value for ushort, and then it's gonna be uint, and then it's gonna be ulong. So hit Control F5, it's gonna run the program, and we will see. So you see 227 byte ushort, then uint, and then ulong. Okay, so let's move forward. I'm gonna commit all these lines. So I'm using a shortcut to commit and uncommit them, which is Control K and Control C. And the same we go here. The next data type in C# is floating points. So the first type in floating points is float itself, which has a size 32 bits. And here I changed my strategy to show the minimum and maximum limits of that data type. So I created two variables, mean float value, max float value, and these data types has a member function which is mean value, and the other one is going to be max value, not mean value, max value. So then I'm printing them the way we learned in our previous video how to print in this nice way. So I'm gonna print them, but then let's go to the next one. The next type is double, which has a size of 64 bits. And the same way we declare two variables of data type double, mean double value and max double value. And here again, one more mistake. Let's fix it. So we have mean and max values in double, so it's gonna be kind of range, you know. So here you have a mean and max value of float, so we will print both of them, and you can just see like what's the range of those values in that data types. Okay, from here on we have another data type which is characters. So before moving forward, I'm gonna commit start commit multi-commit the rest of one. Actually, my multi-commit is starting here and is ending somewhere else, so make sure not to just put some random commits. Let's run this value. So I'm gonna run this program by hitting Ctrl and F5. As you can see, now the values are a bit different, and I will tell you the reason why. So the minimum float value is minus 3.402823 E plus 38. So here it's in scientific notation, which means this multiplied by 10 raised to power 38. It's gonna be the minimum value, and the maximum is like this. For float value for the double, it's this much, which is huge. It's like 10 raised to power 308, which is very big number, to be honest. So I'm gonna commit these two as well. So moving forward, so the next data type is character. The first data type itself is char. We pronounce this as a char. This is character. It has a size of 16 bits. The range is, if you know the Unicode series, I cannot cover that one here, but you can just look for that Unicode. So the range is from Unicode, the first character, which is U plus 4 times 0, to U plus 4 times F, or in this form if you are writing, then it's backslash U 4 times 0 to backslash U 4 times F, and the default value is a bit different, which is like null or empty character, which is backslash 0. So to declare a character, you have to declare and assign a value to a character type variable. You have three different methods or ways. The first one is a Unicode way, so you define the value in Unicode way. The next one is hexadecimal. The third one is just like normal character. Just make sure to enclose the value in single quotes here, because this is character. If you will enclose them in double quotes, it's gonna take them as a string. We're gonna read more about string later on. So this is like that. Okay, so let's commit the rest of the program, and let's run it by Control F5. As we can see, like here the value is same, so it's printing he, and then the third character is Y. Pretty cool. So moving forward, the next data type is, okay, so we were on characters. Yeah, so we were here. So the next data type is, let me just commit this. And the next data type is decimals. So decimals are those values which are presenting like you can present a currency or any other value which has a point in them. So to present those values in C#, you have a data type decimal. So decimal has a size of 128 bits. The default is 0.0, and at the end you put M, which is a suffix for decimals in C#. So here you can see the minimum and maximum values for decimal, and I'm just using the same way I use for the rest of the data types. And here I'm printing the min and max values. So let's just commit the rest of the program and run this one, and we will see the min and max value of decimals. Cool. So I'm gonna commit this one as well. So the next thing is literals. Let's talk about literals in C#. So fixed values appear in the program are usually used for assignment during another computation. So for example, Boolean, we know like they're gonna be either true or false. It's pretty simple. So if you have a variable, it has a value true or false. It's pretty simple. You don't need to assign anything, for example, b here or anything else to make sure that the value is Boolean. But as you know, like for the integral values, we have some literals to make to distinguish between the values. So here I have a value which has a data type long, but to make it explicit, I put L at the end. The same way for decimals. So here L you can put like either big capital L or the small one, but it is best to use the capital one. And if we don't have any suffix in an integral value, the value is considered as decimal. So if you have a value specified in this form 0 and then it has x next to it, and then you have a hexadecimal value, then that value is converted to integer or is assigned or is considered by the compiler as integer value, integer itself. So yeah, these were the integral literals. So the next one is floating literals. Just like integral literals, we also have floating literals in C#, and we use f at the end to make sure that the value is of type float. Then we use d at the end to make sure that the value is of type double. But if it is in floating points and there is no suffix defined, then compiler is taking it as double. Another way is like if you define a value in scientific notation, this is also taken as double. So here you have this 6.21E2. So here you can either use capital or small e. It doesn't make any difference here. The next one is characters and string literals. So as we discussed already, like you can define the character value in Unicode, hexadecimal, or just like a simple character. The next one is gonna be string literals. Strings are kind of special in almost every language. In C#, they are just the collection of characters, and these are enclosed in double quotes. As you can see, for example, I have two variables, first name Tabia, which is enclosed in double quotes, and then I have string variable last name Maxima, which is also enclosed in double quotes. So C# also support escape character sequence. If you already know, like with backslash, we can escape any character. Especially we use them in string, or we usually escape any character inside the string or character itself. The first one is single quote. To make this character escape, we use backslash and then single quote. For the double quote itself, you use backslash then double quote, and for backslash you use double backslashes. For a new line you use backslash n. For carriage return you use backslash r. Make sure to use the small one. The same way you use horizontal tab, it's a tab, or it's equivalent to 4 spaces, all more or less, but it could be more, which is backslash t. Then alter is backslash a. It is actually alert. So the escape sequence for backspace is backslash b. So these are more or less the data types in C#. These are the basic or primitive data type in C#, which are already defined in the language. There are a couple of more, or you can say like the advanced data types or extended data types. For example, for integer in C#, we also use some aliases. For example, you can use int32, int like 64. So you have aliases for almost any data type. For example, for character, you can see it started with a big C, but we're gonna read about them later on. Why do C# actually has those data types? What do we need them for, and what benefits they bring when you use them in your program? And yeah, we will discuss them along the way. We will be covering the other topics too. So for today, that's pretty much it. See you guys very soon. Till then, bye.